So today we're talking about composite transformations. So before we get into this composites, let's review the other type of transformations that we had talked about. Okay, so first let's talk about reflections. Okay, so we had talked about reflections, and there were a couple of ways that we could reflect things. That says reflections in the worst possible handwriting ever. So if we had an x-axis reflection, if you remember, what happened to every single coordinate x comma y? Where did they go when it was reflected across the x-axis?
Y, comma x.
Which one changed and which one didn't?
Y changed.
The y changed and the x did not. So that became x comma negative y, right? The y positivity changed and the x positivity did not change. Okay, what if we had a y-axis reflection? What happened to every point x comma y?
Negative x, comma y.
The x value changed. So if the x was positive, it became negative, and if the x was negative, it became positive, right? Because that was everything in this quadrant went over there. So your x values went from positive to negative, or from negative to positive, and nothing changed with the other one. Okay, and then we had the y equals x line. Remember, that's a 45-degree line, the positive 45 degrees that goes through your origin. Okay, and what happened to all the points on a 45-degree y equals x reflection?
Y, comma x, no.
They did. They, in fact, switched. The x and the y switched places. So if I had a point that was here at 0, 4, that would have reflected over here to the point 4, 0. So when a y equals x reflection, your points switch, right? The x and the y switch positions in your coordinates. And then the last one, if we had a y equals negative x, which is the negative 45-degree line, okay, in that case, each one of these points became their
Negative y, comma x.
they're negatives, just the negative of each other. So if I had this point over here, right, at 2, 2 of 4, then that came over here at negative 4, negative 2. So not only did they switch positions, but they also became negative. Okay, so there's a summary of our reflections. Okay? Now we also talked about rotations. So these are all going to be clockwise. We had 90-degree clockwise rotations, and then a 180-degree rotation, and a 270-degree rotation, also clockwise. Okay, so if we remember, right, these are each of our coordinates. Where did they change to if we had a 90-degree clockwise rotation? So if we had our point here, okay, it came down here as a 90-degree clockwise rotation. So let's just put some numbers here. What if this is the point 4, 4? Right, where did that go? Well, that went to 4, negative 4. So what actually happened is your x and your y switch, but then the x becomes negative, right? The new x becomes negative. All right? I mean, I guess 4, 4 is not a good example because the numbers are the same. So maybe not. So in a 180, right, the numbers just switched. They just became negative. They stuck in their places, and they just became negative as they were. And for a 270 clockwise, the y value, or your new x coordinate, became negative, and the y value stayed the same. Okay, so also, this is a 90-degree counterclockwise rotation, and this is a 270-degree counterclockwise rotation. So those things are the same, 90 clockwise and 270 counterclockwise. Okay, so those are the things that we've done so far. And then, of course, dilations. For dilations, well, this is a marker, not a pen. Okay, if we had a k value greater than 1, that was an enlargement. And if we had a k value, which is your scale factor, less than 1, it was a shrink or a reduction. So those are the things that we've talked about so far. And how you do that is you just multiply each of your points in your coordinate pair by that k value, by your scale factor. Okay, as long as the dilation happens around the origin, these are the ways that we do it. Okay, so now that we've reviewed that, let's go back and see what we're asked to do right now, because the notation is what's really kind of the hard part. So here we have vertices of 2, -1, 7, 2, and 1, 8. So let's plot that real quick. So let's see, we want to first rotate this 90 degrees clockwise around the origin. So a 90-degree clockwise rotation, okay, if we remember, means that we're going to take all of our points and make them, we're going to switch positions and make the x coordinate negative. Right, let's see if that's right. Rotations, yes, switch the coordinates and make the x ones negative. So the first thing we're going to do is change this to y comma -x. Okay, so this is going to be our final composition right there. In one fell swoop, what would we do to all the points if you were given any points rather than just PQR for this composition? And I guess you can't see green very good, can you? Let me change that to something you can see. Okay, so let's do that to all of our points. We have P, Q, and R.
So -1, right?
Okay, so that's our rotation of 90 degrees around the origin. Okay, so now we're at these points. Right, this is our new coordinate system. Here is where we currently are. So we're going to take those points and then we're going to translate them up to and left 6. Okay, so that would be, if we're going to put this in here, we're going to take each of our y values and do what to it?
Add 2.
Nope, we're going to subtract 6 from it. Okay, because it says go left 6. So wherever we're at with our x, right? Now this just says the letter y because that's what we began with. But this is really the x coordinate of these points. -1, 2, and 8. This is the x coordinate of P prime, Q prime, R prime. So we're going to subtract 6 from each of these points. So we are subtracting 6 from your original y value. And then we're going to go up to, which means we're going to add 2 to this. So we had a -x value, and we're going to add 2 to it. Okay, so this would be our notation given any point, not just the 3 points P, Q, and R. Okay, so let's go ahead and do that and see where we end up. Okay, so the P double prime is what we're at now, and now it says reflect this across the x-axis. So what happens when we reflect it across the x-axis? Your x value stays the same and your y value changes. Okay, so the x stays the same and the y changes, which means there should be no change in how we write the y minus 6, but what will change about the -x plus 2? Right, what if we make -x plus 2 negative? What will that end up as? A positive x minus 2. Okay. The negative, let me bring up some space. The negative of -x plus 2, right? Negative times a negative is a positive. Negative times a positive is a negative, is x minus 2. Okay, so we're going to do this, and this is our last one. I will do it in the color blue. So P double prime doesn't change, right? Because it's on your axis. Q double prime goes up to -4 and +5. So Q triple prime is here. I guess this is P triple prime now. And R double prime goes down to below the x-axis for your final transformation. The final answer is blue. Okay, so notice what happened to our notation. Every time you do a transformation, you adjust the notation of the previous transformation. Right? We don't go back to the beginning and have another xy value because we don't have an xy. We have something that has been changed already. So that would be your final answer. Okay, we take the x value by doing the y value minus 6, and you find the y value by doing the x minus 2. So let's see if that is true. All right, p triple prime ended up at negative 7 comma 0. So if we started at 2, negative 1, right? Negative 1 minus 6, what's negative 1 minus 6? Well, sure enough, that's negative 7. And what's positive 2 minus 2? Sure enough, that's 0. Okay? So this final notation should take you from your beginning point to your ending point without having to do all of the intermediate steps. Okay?
Yes.
Okay, let's try it again with this one. We have a reflection across the line y equals x, and then a 180 rotation, and then a translating down 3 units, and then a dilation by a scale factor of 1/2. So this has all of the things. All the things. So let's do it. Let's first plot. First, we're going to reflect it across the line y equals x.
So P would be
So we should switch all of your x and your y points. So here's P.
P prime.
3 negative 4 becomes negative 4, 3. So here's Q. And then R was at 5, 3. So R is going to be at 3 and 5. There's our reflection. And now we're going to do a 180 rotation. So when we rotate 180, you make both of your values negative with a 180 degree rotation. So there's your 180 rotation. Now we're going to translate all of it down 3. So when we translate down 3, I believe just the current y value changes. So we're going to subtract 3 from the current y value. Remember, this is the y position. So we're subtracting 3 from that y position, right? Not from the original y coordinate, but from where we're at right now. Just down 3. Down 3. So there's P triple prime. Okay, and then a dilation by a scale factor of 1/2. So we're going to take half of this, and we're going to take half of this. Okay, and since there's a minus here, I'm going to use parentheses to say I'm taking half of all of it, right? Not just half of x, but half of the whole entire thing, and unfortunately you can't see that very good. Like that. So all of our points are going to be half as far, right? Half as far away as they used to be.
So 2,
So
negative 2.
point is negative 4, so that's going to be halfway here at P. There's P quadruple prime. 4 negative 6 goes to 2 negative 3, right? Because we're halving these points. 2 negative 3 is right in here. Q to the 4th prime. And then negative 3, negative 8 goes to negative 1.5, 4. So this is our final little triangle right here. Okay, and this is your final notation. So to get to the end, you would take the negative 1/2 of the original y value, and you would take half of the negative of the original x minus 3. Okay, and that would be the notation to get from any starting point to this finishing point. Any starting point to that finishing point. Okay? So yeah, it's kind of tricky because you really have to keep your x's and your y coordinates versus positions intact. So it can be kind of tricky.